GECC Environmental Services was commissioned by the Department of Agriculture Regional Field Office 02, DARFO 02, to prepare the feasibility study of the proposed cassava starch processing facility in District 2 of Isabela Province. GECC had conducted the Value Chain Analysis, VCA, for cassava in the region through a participative research involving workshops with stakeholders, key informant interviews, and structured surveys of farmers and traders. The starch mill operation is in line with the Department of Agriculture, Regional Field Office No. 02's commitment to transform the agriculture sector into empowered farming communities through inclusive growth. In general, this study is done to determine the technical, market, financial and economic feasibility of the proposed cassava starch processing facility in District 2 of Isabela Province. Southeast Asia's contribution to global production area of cassava is 18%, yet remarkably, it contributes 28% to global output. In 2016, the Philippines produced 2.755 million metric tons compared to the 2.210 million metric tons production in 2011. As of 2016, Cagayan Valley contributes about 11% of the 2,800 metric tons total cassava production in the Philippines. At the provincial level of Cagayan Valley, Isabela contributes about 76% while Quirino contributes about 17% to the total annual production of 312,717.50 metric tons. The cassava starch production is envisaged to be a post-harvest processing facility to benefit approximately 2,000 farmers of the cassava farming communities, particularly those in the 2nd Legislative District of Isabela. As a market development project, it is expected to provide a level of price support to cassava farmers while maintaining a level of financial performance to ensure operational sustainability. A Mill Advisory Committee, MAC, shall be organized to set the policies and guidelines in the management of mill operations, with emphasis on exercising prudent financial management and accounting practices and setting the purchase price of raw cassava high while maintaining a certain level of profitability for the mill as a business enterprise. Cassava is perishable. It is vital for the harvested cassava roots to be delivered at the processing plant within 24 hours after harvesting, as enzymatic processes accelerate deterioration in the fresh cassava tubers and thereby affecting the quality of its starch. Control of production from the field is necessary in order to operate the mill to full capacity. By consolidating 500 hectares of cassava lands, production can be programmed to meet the mill's daily fresh cassava requirement. Farmers might find it practical to band together and operate as a corporate farming entity under a value proposition that they themselves are the owners, farmers-owned, the decision-makers, farmers-led, and their interest is at the core of their business operations, farmer-centered. It is essential for DARFO 02 to monitor and guide an infantile agro-based industry to become stable and grow to be one of the income-generating industries the farmers could rely on. There is a need from the Department of Agriculture to set the enabling policy environment that will cover farmers from financial risks attributed to adverse selection and extrinsic factors affecting yield and quality. The outlook for the cassava starch industry in the Philippines is bright. The versatility of the product for a variety of applications had enabled the industry to sustain a good market price despite the low prices of substitutes like corn and wheat flours. Given the 60% price increase of cassava starch in the last 3 quarters in the world market, importing will be costlier and therefore there will be an anticipated strong demand for locally produced cassava starch. Demand is expected to grow due to population growth of 2% and due to discovery of additional markets for cassava starch. The project should be able to offer a better deal and still be able to maintain some rooms for downward price movements. The total investment cost of the project including an initial working capital is 25 million pesos. The project is feasible. Financial analysis shows that at the current world price of cassava starch of $540 per metric ton, FOB Bangkok, the project will be able to maintain an operating margin of 18%, which is sufficient to generate an increasing cash flow position year after year. Payback period is less than 2 years. The project is found to be financially feasible with net present value, NPV, 14.5% current discount rate of 36.1 million pesos and a financial internal rate of return, FIRR, of 33%. Economic benefits outweigh costs with a BCR of 1.53%. The IRR is high at 78%, way greater than the STR of 12%. The NPV is 154.5 million pesos. Economic viability is found to be robust. The project is still feasible despite an increase in cost of 20% combined with a decrease in economic benefits of the same magnitude. The BCR, EIRR, and NPV at this scenario are 1.02, 15% and P5.9 million, correspondingly. The cassava starch processing facility will be built on a 1.4-hectare parcel of agricultural land at Barangay Alibadabad, municipality of San Mariano in Isabela. The entire municipality of San Mariano falls into two stratigraphic groupings, 1, Cagayan Valley Basin, and 2, Northern Sierra Madre. The vicinity of the starch mill is situated on a relatively flat area beside a water source, which is one of the tributaries of the Cagayan River. These tributaries are being used as sources of irrigation for farmlands, drinking water, and for catching fishes. If several cassava processing facilities are confined to an area where only a single water source is present, water quality and flow volume might be affected. The direct release of untreated wastewater from cassava starch processing poses detrimental effects to the environment. Cyanide compounds from solid wastes can contaminate groundwater. Sulfur dioxide, which is utilized to control microbial growth and whiteness in starch, can contaminate air. Waste minimization using byproducts for animal feeds can mitigate impacts. Farming system improvements by consciously adopting sustainable farming practices are essential. Improvement in standards of living due to employment and higher income of residents will strengthen their resilience and capacity to adapt to climate change impacts.